Good morning. Today we are going to see column bracket, that is connection of bracket to the column, and on that bracket we are going to erect gantry girder. So you can see this, we have column, so we have provided bracket, so we have this plate on opposite side, that is on other side of the flange. Means if I will draw I section, so we have I section in this fashion, and then we have plate on both sides. So if I will show you, so we have on this side. So this is a plate on one side, we have this plate on other side, and on this plate we have another plate, and which will be connecting these two plates. And on this plate we have gantry girder. So we are seeing only this side, and therefore we are going to get these two lines of web, these as dotted, and we have plate on this side also. So whatever number of bolts we are going to provide on this face, same we have on opposite face also. So whatever number of bolts I will show on section of this bracket or on this side of the bracket, same will be on opposite sides. So you can see over there. So we have drawn this, that is top view, and in that one you are going to see all these value, all these lines. So now if I will say we have 6 bolts on this side, so automatically we have 6 on opposite side also. So now for this connection we have to provide bolts. So in this we are going to consider 25 diameter bolt. Now force is larger, so two types of forces will be developed in this. One force, that is axial force, which will act in downward direction, which is Fa, and another force. So we have Cg. Where we have this Cg, so we have to draw horizontal line which will divide your bolt group in two parts, and vertical line which will divide your bolt group in two parts. So now this is the R which will connect your CG of bolt group and center of bolt. And we have to draw perpendicular line to this, which will gives you Fm, force due to moment. So we have, this is force due to axial value, and we have force which is due to moment, and then we have to find value of a resultant Fr, and that resultant value should be less than your bolt value, and therefore we have to go bolt value. So this is my R is the distance connecting CG of bolt group and center of the bolt, and Fm force is perpendicular to this line. Now our movement is clockwise. Our movement is clockwise because our force is acting vertically downward, and its moment about CG group is clockwise. So this force should also develop moment clockwise. So if I will draw for this bolt, then it is clockwise, so it will be in this fashion. So if I will plot for this bolt, then it will be like this. So these are the Fm forces, that is force due to moment. Fa is always vertically downward, and Fm we have in this fashion. So now we will have single shear and bearing. So bolt in shear, so we have this formula. Now we are considering our failure is in shank, and as our failure is in shank, so my value of nn into a and b becomes 0, and we will get this value 181.38 into 10 raised to 3 Newton. Bolt value in bearing, so we have this formula, I will not go in detail. So it comes 1.5 into DH we have, and therefore it will be 28. So 42 provide 50, 2.5 into diameter of bolt, so 62.5, 70. And then we will put in the formula and then minimum will be KB. So we have 0.58. That will be my value of KB. And we will put this value of KB in the equation of VDPB, and then we will get 232 kilonewton. So minimum of the two will gives me bolt value. Now let us we will first consider four bolts. So as we have four bolts on this face, one face of the column, so automatically four on other face of the column. Let us we have 120 mm this value between the bolts, and pitch already we have 70 mm. Now we have this flange of this beam, and we know this is 250 millimeters. So we are going to provide distance between the bolt, that is 120. So we do not have any criteria how much we have to provide this. Then A we will get, just I explained this. So vertically downward, so my value of FA, this will be 56.03 in vertically downward direction. And 8, we have 4 on this face, 4 on other face. Then we have R. So already I mentioned, now in this case, we have somewhere in between, this is our CG of the bolt group, because we have to divide equal. So we have center of this along horizontal and along vertical also. And R we have distance connecting CG of bolt group and CG of bolt. Now I have this distance. This is 35 because 70 is distance between the bolts. And this we have, that is 60 between the CG of the bolt group and the bolt. And then R value we have this, and this value of R we will get as 69.46. Now these all four bolts we have at equal distance from the CG of the bolt group, and therefore R is same for all. So my force perpendicular to this. So now I will just show it. So we are going to get this force perpendicular to this. Now how the formula will be developed, that I will send you one video again. So this is my value, that is Fm. So now R square we require for the formula. So we have FB PE R upon summation R square. So we have substituted value P we know, E we know. Now R 39.46 and R square. So we have 8 bolts, 4 on this face, 4 on opposite face, and R square 69.46 square. So this I will get actually summation R square, and that we have substituted here, and we have value 229.88. But our value of bolt value is 181, and B is greater than this, so we have to increase number of bolts. So now I will use number of bolts 6. So 6 on this face, 6 on opposite face, so we have total 12. Now if we will go to CG of bolt group in this, so we have center horizontally we have in this fashion, and vertically we have like this. So now we have these 4 bolts, 1 2 3 4, these are at equal distance. And what is value of R? So let us, I will say this will be R1. So how we will find this value of R1? Now we have this vertical distance in this case is 70, and horizontal distance we have 60. And second we have R2. We have R2 for these 2 bolts. Now these 2 bolts, we have same distance, but along the line which passes through the CG of the bolt group. So for these 2 bolts we have value of R, that is 60 mm only. So in this vertical distance is 0. So now you can see 120 we have same, now 70, and then we will calculate first FA 12 bolts. R1 just I have mentioned, we have this value of R1 70 square plus 60 square. This comes 92.20, and 8 bolts we have at 92.2, and 2 bolts we have at 60. Sorry, 4 bolts, 2 on this face, 2 on opposite face. And then we will have R square. So instead of R square, I will mention it as summation R square. So summation R square is 8R1 square plus 4R2 square. And we will substitute value. So actually this value we have summation R square. So we have this as summation R square. So summation R square, and that is equal to 8 into 92.2 square plus 4 into 60 square. 4, 2 on this side, 2 on opposite side, 4 on this side, 4 on opposite side. And we have 840, 6.72. We will put values in this formula same last we have seen. And from this we will get FB 142.93. Now cos theta, we have 60 upon 92.20. How it comes? So now we have to find value of FB in the farthest bolt, and we have farthest bolt is this, and cos theta we have angle with horizontal. So horizontal distance we have 60, means if I will draw bolt, then we have in this mesh. So horizontal distance we have 60, and hypotenuse we got, which is value of R1, and that is 92.2. And from this we will get cos theta, and that value we will get it as, so this is cos theta, and that is 60 upon 92.2, which will be 0.65. Directly I have calculated value of cos theta. And then we have this formula. Now how this formula comes actually, if we have this bolt, then we have two forces. One force, I will send you video of this details also. So we have this force which is FA, and then we have another force which is perpendicular to this. So this is Fm. So this is Fm. And then we have to find resultant of the two. So we have two component of this Fm. One will be in vertical direction, another in horizontal direction. Then find summation Fx, find summation Fy, and you will get this value. So already you have seen this in mechanics to find resultant of the two ports, two force. And this comes 169.6 kilonewton, which is less than 181.38 kilonewton. And then we have to provide 12 bolts, 6 on each side, which will satisfy our requirement. So like this, you have to design this bracket. So now we will stop here only. Thank you.